Welcome to our lesson on inverse trig functions, or in other words, finding angles in a right triangle. Today's objective, we will be able to use inverse trig ratios to find the measure of missing angles in a right triangle. So in other words, we'll be able to solve problems that look like this with a missing angle. Before we begin, let's review some trig, and specifically, let's look at SOHCAHTOA. So here we want to find the sine of each triangle. Now, all three of these triangles are similar, which means that all of their angles are congruent. So, to begin this, we want to make sure that we label all three sides opposite, adjacent, and hypotenuse. So we'll start there, and then we can go ahead and find the sine ratios, opposite over hypotenuse. So when we do that, we find three different ratios, but again, these are similar triangles, which means they have congruent angles. When we simplify, that's what we find, that the ratios are indeed the same, which would make sense if the angles are congruent. But still, how do I find that angle? Well, an inverse trig ratio, or an inverse trig function, undoes that ratio, allowing us to find the measure of the angle in a right triangle. So if I had a triangle like this, where theta, opposite, hypotenuse, and adjacent are there, we could have our three trig ratios, sine, cosine, and tangent. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. The inverse allows us to solve for theta. So what happens is when I do the inverse, I have sine inverse, that little -1, and then I have the ratio inside now and theta on the other side. So they've swapped places. And the same thing for cosine inverse and tangent inverse. Now, as a note, sometimes these are called arc sine or arc cosine, arc tangent. They mean the same thing if it says arc or if it has that little -1. So just be aware of that. Let's do a couple examples here. Find the measure of each angle, round to the nearest tenth, or in other words, 1 decimal place. The first thing we need to do is pick a theta and then label the sides that we have measures for. It doesn't matter which angle you start with. I personally like to start with angle A because that's alphabetical order. So I'm going to label theta, and then I'm labeling opposite and adjacent because those two sides have side length measures for them. So those are going to be helpful. So step 1 is set up a trig ratio using an angle. Because I have opposite and adjacent, I'm going to use tangent. So tangent A equals 20 over 15. Now, normally we would simplify this and reduce it, and you can, but because we're going to be finding that angle measure, it does not matter. After you've written your trig ratio, go ahead and rewrite it using the trig inverse function. So what you do is you do tangent inverse, that little -1, and then swap the spots of the ratio and the angle. So now tangent inverse, my ratio, 20 over 15, equals the measure of that angle I'm looking for, A. And at this point, we just calculate. To put this into a calculator, you need to hit second tangent to get that inverse. And then 20 divided by 15 and hit enter. So there I have the steps typed out for you. Second tan 20 divided by 15, enter, and you should get 53.1 degrees for the measure of angle A. If you are not getting 53.1 degrees, you need to make sure that you are in degree mode, not in radians. If you need help with that, go into Google and type in your calculator model and type in degree mode. So TI-84 degree mode, and search that, and it will help you be able to do that for whatever calculator you have. This problem, though, does not just want measure of angle A, it wants all three angles. So we are going to use the triangle sum theorem. We know that angle A is 53.1 degrees, and angle C is 90 degrees. So angle B would be 180, and then subtract those two angles, giving us 36.9 degrees. Again, that's just the triangle sum theorem. All three angles add up to equal 180. Let's do another one. Same thing, find the measure of all the angles and round to the nearest tenth, or in other words, 1 decimal place. So start off with picking a theta and labeling the sides that we have measures for. So here I decided to do angle B first just to show you how that would work. So I have adjacent and I have hypotenuse now if I'm looking at angle B. Set up your trig ratio using the angle. So cosine B is 3 over 9 because cosine uses the adjacent and the hypotenuse. Rewrite that using the inverse trig function. Cosine inverse, your ratio, 3 over 9, equals the measure of angle B. And at this point, you just type it into your calculator. Buttons being second cosine 3 divided by 9, enter. And the measure of angle B is 70.5 degrees. We still need to find the other two angle measures. So if angle B is 70.5 and angle C is our right angle, 90 degrees, we can use the triangle sum theorem to solve for the measure of angle A. 180 minus 90 minus 70.5, and the measure of angle A would be 19.5 degrees. All right, let's do another one. Same thing. Find the measure of each angle. Here I'm going to start with B again and label my sides. So now I have theta at B, and I have my sides labeled for opposite and hypotenuse where I have side lengths. Set up my trig ratio. So sine of B is 36 over 53, and then rewrite that using an inverse trig function. Sine inverse of 36 over 53 equals the measure of angle B. And now angle B is all by itself, so we are ready to calculate. Type it into my calculator, and the measure of angle B is 42.8 degrees. Now go find the measures of angle C and angle A. So angle C is 90 degrees because it's marked as a right angle. In angle A, we use our triangle sum theorem, and we find it to be 47.2 degrees. All right, example number 4 is for you to try. Find the measure of each angle and round to the nearest tenth. Here are the steps to help you remember. Now go ahead, press pause, find the measure of angles A, B, and C. Okay, I'm going to put some work up here. There are 2 ways you could have started this problem. You could have started by looking for angle A or by looking for angle B. So on the left side is all the work to find angle A, or if you started off by looking for angle B, that is on the right-hand side. So don't try to do both of these. Compare your work to the work that's shown, but use the angle that you used, okay? And remember, triangle sum theorem to find that last final angle. All right, so this brings us to the end and things to remember. We have a right triangle here with theta labeled and the 3 sides labeled as opposite, adjacent, and hypotenuse. So an inverse trig function undoes that trig ratio, and that allows us to find the measure of an angle in a right triangle. So those are our sine inverse, cosine inverse, and tangent inverse. And the process or the steps to find theta: set up your trig ratio using any angle, rewrite that ratio using an inverse function, and then calculate. And that is it for this lesson.